My name is Ali, and today I will be guiding you through the exciting and transformative world of using AI to predict disease. We're going to cover a lot of ground, from the basic of machine learning to a live demonstration of predicting heart attack using Python. Before we delve in, I would like to extend a heartfelt thank you to the Green Organization for hosting this webinar, providing with this platform to explore the future of healthcare together. Let's get started. We are going to start with the basic of machine learning. Machine learning is essentially a subset of artificial intelligence that focuses on building systems that actually learn from making decisions based on data. It can be categorized to the two major parts: machine learning workflow and types of machine learning. About the machine learning workflow, we can say that workflow typically involves several stages: data collection, data preparation, model training, model evaluation, and model deployment. At the first slide for this matter, as you can see on this screen, the simply putting data, and the data collection is a process of actually gathering relevant data to your AI project goals and objective. You eventually update a data set which is essentially contains your collection of data, and it can be trained and fed into the ML model. About the next slide, we have the second phase of machine learning workflow: data preparation. It means the process of preparing raw data so that it is suitable for further processing. It includes collecting, cleaning, and labeling raw data to a suitable machine learning algorithm. Another step is about the model training. Choosing actually appropriate algorithm, training their model by fitting it, and tuning hyperparameters through interactive process. It can even optimize our process. So the model training is a process to get better at practicing. Model evaluation actually aims to estimate the generalization accuracy of a model and future. Methods for evaluating a model's performance are divided, namely holdout and cross-validation. About the model deployment, it is very important part of this section, this workflow, because at the final part you can easily visualize your content, your algorithm, or all of your data that is processed by the machine learning algorithm. It is integrating into a product environment, actually, monitoring its performance, or even ensuring scalability, or maintaining the model by updating or even retraining it with new data. And actually can be used for such a live application. I have developed an UI interface for you for this project, and we will discuss about it. About the types of machine learning, I have to say that we have three major types: supervised, unsupervised, and reinforcement. But the supervised, we train model if actually we train models using labeled data, which means we have input and output pairs. In this part of learning, the model learns to predict the output from the input. And very normally and very popularly, the inputs are known as features or X variables. And the output is generally referred to as the target or Y variable. You may have seen some charts and diagrams that X-axis contains your raw data and Y-axis is completely dependent on the X value within some equations. About the supervised learning, I have to mention that we have two major subcategory or classes that is extracted from this type of machine learning. For classification, we have four major parts or algorithm we can precisely say about it. The first one is about support vector machine or SVM, a method that finds the hyperplane that best separates different classes into the feature space. About the random forest, it is a very high profile, well-known method that builds multiple decision trees and mirrors actually their prediction. About the random forest, we told about it, and we will use it in our live presentation. About the k nearest neighbor, it's a non-parametric method that is classify actually the data point based off the majority of classes among its nearest neighborhoods. And about the fourth one is about decision tree. It is a tree-like model where each internal node represents a test on an attribute. Each branch represents an outcome of test, and each leaf node represents a class label. And about the regression, very popular and very useful kind of algorithm. It is very similar to decision tree, but used to predicting continuous outcome. But the Bayesian model, it is used to update the probability distribution of a model as more data becomes available. And about the regression analysis is a kind of statistical process for estimating the relationship actually among variables, typically focusing on the relation between a dependent variable and or even more independent variables. About the unsupervised learning, it is a fundamental type of machine learning. This approach would focus on input vectors without corresponding target values. It has actually been remarkable development and ability to group or interpret information based on similarities or patterns and differences. And it has very differences in comparison with the last one, the supervised one. And about the description of this type of machine learning, we can distinguish between two cluster analysis and dimensionality reduce. As you can see on this screen, the cluster analysis aims to group a set of objects actually in such a way that objects in the same group are more similar to each other than those in another group. One of the major algorithms used in this category is k-means, is a method that partitions two data into k cluster, where each data point belongs to the cluster with the nearest mean. About the hierarchical clustering, it is another method that builds a hierarchy of cluster by either merging or even splitting existing cluster. And about the Gaussian mixture model, it's another model that assumes the data is generated from a mixture of several Gaussian distribution with even unknown parameters. And about the density-based clustering, it is very well known as a method like dbScan that defines clusters as an area of high density, separated by areas of even low density. And about the dimensionality reduce on the right side of this screen, you can see the principal components analysis, independent components analysis, and factor analysis. For example, the factor analysis is a technique used to identify underlying relationship between the variables by modeling the observed variable as a linear, actually, a combination of potential factors. And the third one, the third type of machine learning is completely different in comparison with two last ones. In reinforcement learning, as you can see, it is completely based on an agent that is learned to make a decision by interacting with an environment. It receives feedback in the form of rewards and penalties based on its action, and allowing to learn the optimal behavior to achieve its goals over time. For example, some kind of games that are designed for this purpose, working to interact with the user and even give you rewards or penalties, and this algorithm works better. As you can see on this screen, it's a very brief overview of reinforcement learning. On the left side, you can see that we have input raw data. Machine learning is based on the data, any data that you fit it. This is the starting point of the RL process, where raw unprocessed data is fed into the system. The raw data can be in various forms, including numerical, categorical, textual, or even image data. And also, you're able to take a look at the middle side of this diagram. We have environment module represent the context or external system which the agent interacts. It provides feedback in the form of rewards or penalties based on the action taken by the agent. The agent is a decision maker in RL framework. It interacts with the environment by taking action and learning from the outcomes. About the state, as you can see here, this is an object represents the current situation or configuration of the environment as perceived by the agent. It is a snapshot, actually, of all relevant information at the particular time. About the reward, after agent takes an action, the environment responds with a reward. This reward is a numerical value that indicates the immediate benefit or even the cost of the action taken. The agent uses this feedback to adjust its strategy. The module best action, as you can see here, it selects the best action to take based on the current state and learn policy. So the policy is a strategy or mapping from states to action that agents have developed through learning. And finally, on the right side of this diagram, it is depicted that the output and the most important part of any machine learning is located here. The final result of our RL process can be optimized policy, a trained model, or even specific action that achieve the desired goal. The output is depicted as a different cluster, as you can see, or patterns representing the learned knowledge or even the decision. Overall, we can say that this diagram represents a cyclic process where the agent continually interacts with the environment, learn from the feedback, and improve its decision-making policy to achieve optimal performance. About the next slide, it is about the overview of algorithm. We have mentioned three major algorithms here: the regression models, decision trees, and random forest, support vector machine, or SVM. About this diagram, as it is depicted on this screen, we have 5 types of regression. But the most popular one is linear regression, which is used actually for predictive analysis. And it is a linear approach for modeling relationship. So it is used for predictive analysis. Linear regression is a linear approach for modeling relationship between the criterion or scalar response and the multiple predictive or explanatory variables. Linear regression focuses on the condition probability of distribution of the response given the value of predicted. The decision trees and random forest. A decision tree is the most powerful and popular tool for classification and prediction. A decision tree is a flowchart-like tree structure where each internal node denotes the test on an attribute. Each branch represents an outcome of the test. And as you can see, each leaf node, we can say the terminal node, holds a class label. The goal is to create a model that predicts the value of target based on several input variables. As you can see on the bottom of this picture and slide, we have an algorithm, for example, very simple prediction score that if, for example, a guy or an individual is upper than 15 age, the result is yes, and the score is -1. But if an individual is male and is upper than the 15 age, can get +2 score here. About the SVM or support vector machine. It is a type of actual supervised one algorithm used in machine learning to solve classification and even the regression tasks. But it's particularly good in solving binary classification problems, which has been shown here. You can see that 2 major classes are separated on this chart. Let's continue to an overview on our data set. Machine learning actually works with raw data as an input, a data set. So I'm going to explain it very briefly. We use a data set that includes information from even 4 databases: Cleveland, Hungary, Switzerland, and Long Beach. Actually, the dataset has 76 attributes, but for our experiments, we focus on only a subset of 14 key attributes that is very important and are most relevant actually to heart disease. Our goal is to predict whether a patient has heart disease based on these attributes. The target field indicates the presence of heart disease, which one representing a positive diagnosis and 0 representing a negative one. As you can see on this screen, it is an overview of our dataset. It has 13 attributes such as age, sex, CP chain type, TRTBPS, and so on. As you can see on the right screen is a snapshot of the dataset. It has some records. It's more than 300 records of valid data. Let's delve into the detail of the parameters. The first one is CP or chain pain type. Angina is chain pain or discomfort that happens when your heart isn't receiving enough oxygen-rich blood. As you can see, it can be distinguished to 4 major values. For example, value 1 is for the typical angina. The value 2 is for a typical angina. The value 3 is non-anginal pain, and the 4th one is a symptomatic one. The next attribute comes to TRTBPS. It's a resting blood pressure in mmHg. This parameter actually indicates the force exerted by circulating blood on the walls of the arteries. When the heart is at a rest between beats, resting blood pressure is a critical, as you may know, indicator of cardiovascular health, with normal values typically around 120 on 80 mmHg, or even elevated resting blood pressure, known as a hypertension, actually can increase the risk of heart disease or stroke or even the other health issues. Monitoring TRTBPS is very essential for diagnosing, managing, and even the preventing hypertension in this case. Other parameter is CHOL, cholesterol, very popular, very well known parameter in mg deciliter. It refers to actually a fatty substance essential for building cells and producing certain hormones. But high levels can lead to buildup of a plaque in arteries or even increasing the risk of cardiovascular diseases such as the heart attack and stroke. The next parameter is FBS, fasting blood pressure. It stands for, it's an abbreviation of fasting blood sugar. It is measured in milligram per deciliter, and it is classified to 2 major values. If the value is upper than 120 milligram per deciliter, it means the value is 1. And if the value, or maybe the attribute, comes to lower than 120 milligram per deciliter, it means the value comes to 0. About the next slide, it's another attribute, REST-TECG. Refers to resting electrocardiographic results, which are used to evaluate the heart's electrical activity while the patient is at rest. This result actually typically classified to 3 categories. First of all, is about normal. The value is 0. And you can see it indicates a normal resting ECG. And on the right side, you can see a picture of this value. The value 1 refers to T wave abnormality, indicates the presence of some abnormalities such as T wave inversion. This change even can suggest myocardial ischemia or other condition affecting the heart's electrical activity. On the next slide, the value 2 means that the left ventricular hypertrophy by Estes criteria, it indicates the probable or even definite left ventricular hypertrophy, LVH, which is an enlargement or even thickening of the walls of the heart's left ventricle. About the THALACHA, it refers to maximum heart rate achieved. This test actually involves gradually increasing a physical activity. For example, using treadmill or a stationary bike to evaluate how the heart responds to physical stress. It is influenced by factors such as age or even the fitness level, medication, even the overall health. The next slide is about EXNG, exercise-induced angina. It is categorized to two major values. If the result or the value is yes, it means the value comes to 1. And if the attribute is equal to no, it means that the value should be 0. About the old peak or previous peak, the term old peak refers to a state depression in an electrocardiogram measured during peak exercise relative to rest. As you can see, it is classified to 4 major values. For example, the value 0 means no significant ST depression has happened, and for the value from 0.1 to 1 means a mild type of depression has happened. And the value more than 2 means that severe ST depression and actually indicates significant ischemia and even the potentially severe CAD. We can see the slope, SLP. It is, ST segment actually shift relative to exercise-induced increments in heart rate. The ST heart rate slope has been proposed a more accurate EC criterion for diagnosing significant coronary artery disease or CAD. And as you can see again, 3 value types, 0, 1, and 2, demonstrate least concerning, suggestive of myocardial ischemia, and highly concerned about this value. The next slide comes to a number of major vessel color by fluoroscopy. It's a parameter typically range from 0 to 3, sorry. And it is representing the number of major vessel with significant stenosis. As you can see, for example, for the value 0, it means that no major vessel colored, and for the value 3, it means that 3 major vessel colored. The next slide gives us another attribute, THAL, means the Talon stress test result, and it refers to the result of Talon actually test result, and actually also known as a myocardial perfusion imaging, even the MPI test. And again, we can see the distinguished items and values here from normal to severe ischemia or high risk features. About the most important field, actually, let's keep moving. Look at it, which is here attached to this slide. It means that whenever we are facing with the output 1, means that the positive heart attack has happened. And if the output value comes to 0, means that negative heart attack has happened. So it is all of this stuff that we have talked about them, working with the machine learning, or all of this stuff are the attributes. We are working with them to give or to get even the outcome as an output, 1 or a 0. So it is the most important value because, in the process of learning and training, or maybe testing the machine learning, we normally select some bunch of data from the raw data to fit in as a training, and some bunch of data for testing. And the output is playing a very vital role in this regard. About the live demonstration, let me briefly explain what we have talked about. First of all, we have reviewed some algorithms, some parameters, the dataset overview, and here we are going to even practically use all this material using the Python, using the VS Code, and the Streamlit. First of all, let me elaborate on this slide. Whenever you are willing to predict some issues like heart attacks using machine learning, you have to use some tools, very practical ones, very popular ones. For example, the Python. Python is an actual high-level interpreter programming language known for actually its readability and simplicity and versatility. It is very widely used in web development, data science, artificial intelligence, and scientific computing, and more. VS Code is a Visual Studio Code is a free open source code editor developed by Microsoft. It is actually highly customizable and supports a wide range of programming language, including Python. It means it's a kind of IDE. If you may have experience working with software, developing a program, you may have even faced with this kind of IDE. Streamlit is an open source Python library. Whenever you are using Python for your development, you can use a wide variety of libraries. For example, for demonstration and visualize your codes, you can use this library, creative, interactive, web-based application very quickly and easily. It is designed for data scientists and machine learning practitioners to turn their models and even to visualize their output. So let's get back on track and continue with our ID and code. So let me share the VS Code editor. I am gonna explaining very briefly, and I want you to concentrate on even some lines of these codes. For example, if you want to use Python for your data science, like the machine learning, you have to use some libraries like pandas, like NumPy, scikit-learn, matplotlib, or Streamlit. As you can see here, I highlighted it. I imported a library, Streamlit, and in another part of my code, I have developed a function, draw confusion matrix. It means that some calculation will be happened. Or here, I have developed some codes to run machine learning algorithm. For example, if I choose the KNN, one of the major algorithms that we were talking about, the processor, the interpreter will work on each line through the codes based on the condition or the functionality of each script. For example, here I imported the k-neighbor classifier and another algorithm completely have been shown. So this is the editor. This is the VS Code editor. You can use it on your own. This is completely free for all of you. You can download, you can install it, and using your Python codes. As you may have known, the files for Python programming has the extension of py. So let's get back on another amazing interface and UI that I have developed before for this module. Here, as you can see, this is the web interface that I have developed using VS Code and the Python and machine learning algorithm using the dataset hard attack as a CSV file. As you can see, it has about 40 attributes that we were talking about them one by one. For example, if you can see here is about the age of person or individual. This is the CP or champagne type. This is the TRTBPS attribute, the cholesterol, and other ones. All of this stuff, all of these attributes are completely and dynamically implemented on this interface. You can easily even drag it to the lower level or upper level. So let me explain very briefly about this interface. I have developed it. As you can see on the left side, you have some capability, some combo boxes you can choose from. The classification machine learning algorithm, you can choose your algorithm. For example, for default value and algorithm, the KNN is selected. And some default attribute has been chosen, the test size, the neighbor's value, and the final and the most amazing part of this interface is the prediction. As you can see, by default, within very default value of all these attributes, the machine learning using this algorithm gives us the prediction output positive or 1. So if you use this machine learning with the accuracy around 63 for the testing part of your raw data, you can get a result of positive heart attack has happened. But we can even work with this interface. I have chosen before, let me show you this records. I have chosen for you some samples of data. For example, for the positive one, we have an individual with the age of 37, CP with 2 value, TRT-BPS around 130, cholesterol is around 250, FPS around 0, and the other values. So let us check it right now, very practically and lively. So I'm going to use this algorithm. First of all, I chose the KAN algorithm. I try to give this age around 37. The CP comes to around 2. The TRT-BPS is around 130. And the cholesterol is around 250. The FPS value is 0, so I change it to 0 value. The rest ECG is around 1, so I change it to the 1. And THALCHH is around 187. And the EXNG is 0 value. Old peak is around 3.5. SLP, slope, is around 0. CAA is 0. And THAL is 2. So we increase it to 2L. As you can see, this is the prediction of machine learning. So the accuracy is completely 100% because we have trained this machine learning with these bunch of data for more than 300 raw data value valid data. And we can, check it right now. Let's check another one for the negative side. I'm going to check, for example, the first row with the age 43. As you can see, it is completely positive. So I'm going to change all of these variables and attributes online using this interface, using the machine learning algorithm KNN, one of the major and important regression algorithms used for all of this stuff. So I have to change the age to 43, and the CP comes to around 0. The TRT BPS is around 132. The cholesterol comes to around 341. FBS is 1, we change it. Rest TECG, it's around 0. THALSCH is around 136. And EXNG is 1, we change it. Old peak is around 3. So we have to increase it to this new number. And this LP is around 1. The CAA is around 0. And the THALL is around 3. As you can see, the result comes to negative. It means that whenever you're facing with an individual, a patient, with these attributes, it means that machine learning can help you to predict the heart attack possibility. A person, a guy, 43 with these parameters has this prediction time. So we can even play with this value. For example, if I'm going to increase it to some new values, for example, I increase it to 169 value. And you can see the prediction by machine learning, by artificial intelligence background, or, technique or technology comes to a positive. So it can very simply and very obviously demonstrates us that even changing some very, precise values of some attributes can change the prediction type. We have gathered more than 76 attributes on this data set, but we have chosen only 14. And if I increase a value for THALCHH from around 122 more than 170 or 8, the negative prediction comes to a positive one. So This is completely and dynamically works using some machine learning algorithm that we were talking about. What we have to pay attention to very important issue right now, This is very important that any algorithm of machine learning has its own practically side of working. I have even developed a confusion matrix. It's a concept. It's a very technical issue for machine learning because it has a chart, a diagram that can gives you, some values, and you can compare the accuracy or something like this. I think it is not important right now for you to focus on it. But it is very important that if you change even some algorithm to another algorithm, for example, I'm going to change it to SVM. And the value, let me change it to the default version, 132 for this. As we checked it before, the prediction was negative, but let me change it to another algorithm. For example, the naive bias or even the decision tree. All of these algorithms work correctly in this special information and raw data. But sometimes you may face with some even some problems or maybe some differences between algorithms to predict. Sometimes one of the algorithm works very better than the other. So it is based on you, on your skill. We have a concept of domain expert. It means that in a medical issue, a personal guy who is completely, have knowledge about the medical issue and work with machine learning can be as a kind of domain expert. But in comparison with this special, profession, we have some another experts working with machine learning, and they don't have any idea about your information or data in your field. So it is very important to work together to use very profitable, very accurate algorithm based on your domain expert. As I told you before in this webinar, we have a bunch of different algorithms. KAN, decision tree, logistic regression, SVM. Each of them works sometimes better than the others. So it is completely based on your experience and even on your skill. We can even check another one if you're willing to do, but I think it is enough for this demonstration. So I think we have some knowledge, we have some idea about working artificial intelligence, specifically the machine learning with another domains like the medical issue or another industries. Or actual web interface aims to provide a user-friendly platform for visualizing and understanding. But sometimes you may have not an opportunity to find any UI or interface to work with it like this, interactively. So sometimes you have to develop a code and get your result only based on your knowledge and your information and your scripts. So let me overview of all of information or on stuff we have discussed about it. First of all, we were talking about the machine learning, the types of them, and the algorithm we have in this area. And after it, we have experience, a valid and real dataset contains from more than 40 attributes based on real samples. And on the final part, we have reviewed an UA, an interface that is completely show us that how we can interact even the interface that works with machine learning, with algorithm, with some raw data, and it can even help you as your domain experts to predict some illnesses and some diseases. For example, for this special webinar, the heart attack. Let me let me talk about another, I think, important issue. As we conclude our webinar, it is clear that the future of healthcare is being completely transferred by capability of machine learning. But the accuracy and reliability of disease prediction models are completely and directly tied to the quality of raw data used for training. This is very important. As you saw in our webinar, the raw data are very important. But if you're gonna get more accurate values and information and outcome using machine learning, you have to fit the machine learning with a bunch of data. If you can, for example, picture that you're gonna use this kind of algorithm to predict heart attacks. If you can feed more than 1,000 real values and real attributes, even you can get more accurate. As you can see here, very simply, that the accuracy comes to around 63%. That is not actually very high in reality. So we have to consider that. It is very important to consider about the quality of your raw data. And I think it is a very imperative to ensure that data is clean, comprehensive, and actually representative of real world scenarios. And I think looking ahead, potential for AI to predict and even to mitigate disease outbreaks can even improve patient outcomes in the future. I'm encouraging you to engage deeply with the real samples and data sets to refine all of these models. I think advancing both your skills and the field of disease prediction can help this stuff, help medical experts, AI experts, and all of us actually. Thank you for your participation, and I will look actually forward to seeing your contribution in this exciting domain.